Hello and welcome. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today is the long awaited for part 3 of our Predicting the Stock Market series. And in this one, we're going to be looking at how to put together another data set. It's going to be a little different than the last time. The last one, we were predicting an individual stock and what the price was going to be in the next step. Now we're going to be putting together a whole bunch of stock data for the entire S&P 500, and we're going to be figuring out which stocks we should be investing in and which ones are going to give us the most return over a year, a quarter, whatever interval that you want to set. So let's jump over to the Jupyter Notebook and start putting together that data set. Okay, as you can see, we have our Jupyter Notebook up and ready to go. But before I start coding, I do want to show you some fundamental data sources that we're going to be pulling this from. And it would be super important if you're going to be looking at predicting your own stocks or even just dabbling in the financial market. So if I open up a new tab here, what we have here is this is an annual report that companies are required to submit. And this one is actually Tesla's. So this is Form 10K, and this is their annual report. 10Qs are the quarterly reports. And basically what's in here is a whole bunch of company data on their revenues and where they're getting money from and what debts they owe. And there's just a whole bunch of stuff within here that we can pull from. So I'm just going to show you some of that. If we scroll down that document a little, the document's fairly long and has a whole bunch of stuff in it. So there's a lot of information in it. But these charts are what we're looking for. So this one is the balance sheet. And the balance sheet is going to show the assets, the liabilities, the equity, and it's going to just have them split out into different sources and show how much money is dedicated to each one of those or coming in from one of those, depending on whatever it is. But there's a lot of useful information here that we can use, and also we can take these and build our own indicators by manipulating a bunch of these and putting them together. So that is the balance sheet. Other ones, this is the cash flow. So this shows where all the money is going and where all the money is coming in, so that you can see the different sources. And then the last one I'll show you is for revenue. You can see this is the sales and the revenue data. And all of these have it over a few years. So this one has 3 years worth, just to compare like the upward trend here of the automotive sales. So lots of useful information there. This is where we're going to be pulling our data from, is all of these different charts. And then we're going to be making some indicators based on some trends that we're seeing within the charts. So let's go back to the Jupyter Notebook. And we can go ahead by, like always, importing our libraries. So we are going to be importing pandas. We are going to be importing NumPy, Matplotlib, Plotly. Oh, sorry, PyPlot, not Plotly. I'm going to be doing that as a PLT. Okay, so those are data manipulation, data visualization. Now we're going to be importing Y Finance as YF. So this is Yahoo Finance. This is where we're going to be pulling all of our data from. There's some other APIs and packages out there that you can use, but this is just an easy one that I'm able to quickly pull the data from. And the last two that we'll do is just getting date time formats and tools to use time. So from date time, this is date time, import date time, and then we are going to be importing time. Go ahead and run those, get those packages in, and we will, oops, I deleted that there. Go ahead and get those packages in, we will move on. Okay, so if you remember the last time, what we did was we pulled all of the tickers, and the tickers, again, are those abbreviations for the stock. So they're just like shorthand for whatever the stock is in order to reference them really quickly and not take up a lot of space with the long name. So when we pulled the tickers the last time, we actually went to Wikipedia, and I have the page up right here. And we went to this wiki page, and this is for all of the S&P 500 companies. And we went to this table, and we pulled all of these tickers from this first table, the symbols column. So let's go ahead and do that again. I'm going to copy the link to that website, and we're going to be using pandas to read that in. So I'm going to call this tickers is going to be equal to pd.read_html. pass in that website name. Go ahead and pause the video here if you need to copy down that website. But I will keep typing. So what we want is we want the very first table within that wiki site. So we're going to take the first table that pandas returns, and then within that table we want the very first column, and that column was called symbol. Okay, so this will give us all of the tickers. Let me go ahead and print that to show you that it's working. Yep, and there you go. We have all of our tickers here. There's actually 505. I believe a couple of these are delisted, so we will handle that when we get to those, but we have all the companies that are currently in the SP500 right now within that list. Okay, so what we are going to be doing is we're going to be iterating through each of these tickers in order to build our data set for each one of those tickers. So I'm just going to do a simple for loop. So for ticker in tickers, we're going to be doing something. Now, like I mentioned, some of those tickers are delisted. So when we start to do and pull some of this data, we're going to run into errors because the ticker doesn't exist, or it used to exist and there's not enough data, or it's a brand new ticker, so there's not enough data. So we need to kind of handle those exceptions. And the way we're going to do that is we're going to use a try and except. So the format is something like this, where we have a try statement, and that try statement is going to try to execute whatever's in this portion right here. And if it can, great, it'll just move on. If it can't and something raises an error, then it's going to jump to the except statement and execute some code. So it's a great way, especially for this, when we have 505 tickers that we're going through. If we run into an error on 490, we don't want it to stop everything and have to address the error and then start over again. Instead, what this is going to do is just going to skip over that ticker and show what the error was for that ticker, so that we could go back and address it if we wanted to. So I'm going to just complete this except statement. So I'm actually going to say except exception. So this is a capital E. I'm going to say accept exception as E. So what this is doing is taking whatever that error was, saving it as a string that's called E, and then we can go ahead and print the ticker that we're on, because I want to know what stock it was that we had this error, and then I want to know what the error message was. So if we run into an error up here, then it's just going to print whatever one it was. Okay, but for the try statement, this is where we're going to have all of our code that we're trying to execute. So the first thing we need to do is in Y finance, we need to say which ticker we are looking at, and I'm going to call this stock. So it's going to be yf.T ticker, and we're just going to pass in whatever ticker that we're looking for. And this is just going to say, okay, here's the stock I'm looking for, and then from there we can pull all of the data. And so to show you that, I'm just going to call this info. We're going to say stock.info, and I will go ahead and display this to the screen. Now, what this is going to do is going to pull the company info. There's going to be a lot of it, so I'll show you what that is. But before I do that, I'm going to go up here to the for loop, and I'm just going to say I want the very first ticker, because I don't want to sit here and wait for it to execute 505 times. I just want to do it once. So go ahead and display that info. Now, there's a lot in this one, so it probably will take a second to load. It didn't take that long, actually. Okay, so info is exactly what it is, just general information on the company. So zip code, there's a summary of what the company does. This is the 3M company, what sector it's in, how many employees it has, a whole bunch of stuff, where it's located. And then down here it has a whole bunch of indicators that were built. Now, these indicators are for the current company, right? So the current year, and they are not for the previous years. So there's a lot of useful information here, but it doesn't have any historical data, which is why we are actually going to be building all that historical data ourselves. But for now, we can pull a lot of the general information out of here that we can use for our predictions. So we will take that one. Now, if you remember from the Form 10K that I showed you, there was something called a balance sheet. So we can actually pull that. I'm going to just call this balance. And that's going to be equal to stock.balance_sheet. This is going to pull the yearly balance sheet. If I go ahead and display this, go ahead and run that. Now, if you wanted the quarterly balance sheet instead of the yearly, you can put quarterly in front of this. So it'll look something like this. And this will just pull the last 4 quarters instead of the last 4 years. But we want the yearly, so I'm not going to worry about that. Now it printed, and you can see over the last 4 years, we have values for all of these different assets and liabilities that we can pull from. So we will return to that when we start making some of the indicators. Next one is going to be something called financials. This is just more data from the stock. So it's going to be dot financials. And I will print this one. While that's loading, next one is going to be earnings. So it's going to be stock.earnings. And just going down here to the output, you can see this is the financials. Again, more revenue and income values that we can use. Go ahead and import earnings. I will print this one. This one should go fairly quick. There's not much data to this one. Yep, so you can see over the last 4 years, we have revenue and earnings. And the last one we're going to do is cash flow, which is equal to stock dot cash flow. Pretty easy. All right, and I'll just print that again just to show you what it looks like. Okay, you can see a bunch more information over the last 4 years. Now, one thing that we do need is, okay, we have all of this data for how the company was doing the year before, but this doesn't tell us how the stock was actually doing. So we need to pull these historic stock data. Now, as you can see, there are dates up on top of these columns of whatever year that we're looking for. So it goes from 2021 to 4 years back. Now, I can tell you this is not the same for every stock. Some stocks are going to have, it's going to be off by a year maybe, or it may even not have all 4. So instead of just hard coding these dates into it, we kind of need to just look at what the date is from these tables and then use those as our inputs for the historic data. And I'll show you what I mean right now. So we're going to make a value called start dates. That is going to be equal to, let's just take the balance data frame, and we're going to say the balance dot columns dot values. Now, this is going to be like the one right here. It's going to be pulling these 4 values. And what we would want is we want from that date, we're going to be predicting the year after it. So we need to make end dates equal to the start dates plus NP for NumPy dot time delta 64. So these columns are actually stored in NumPy datetime. So we are just going to be adding a year to whatever those are to get the end dates. And actually, I'm going to be adding 366 days because this is the last day of the year, but I want the first day of the year to the last day of the next year. So 366, and we need to say that it's in days. Okay. Let me print the start dates to show you what those look like. Okay. As you can see, these are in NumPy datetime format. So it is the date at the beginning, followed by a T, and then the time with a whole bunch of decimal places. Now, the only thing we really need from these dates is we just need this date portion. So we are going to just be exporting those from the string. So we're just going to tear apart the string and only pull out the date. And to do that, we're going to say start dates is going to be equal to, we're going to make a list here. So it's going to be equal to the string of date. And then we're going to take everything up till the last 19 characters. And the reason the last 19 is because I'm taking this string and I'm getting rid of all of this stuff for the time. And those are 19 characters. I already counted, so you can go ahead and just trust me there. And so we're going to say we're going to do that for date in start dates. So just going through each one of those 4. converting it to a string, and getting rid of the time. Go ahead and copy this because we're going to do the same exact thing for the end dates. And go ahead and run that. Now you can see we only have the dates. We don't have the times anymore. So we can go ahead and use this to pull our historic stock data. I'm going to delete this print statement for now. And instead of doing one massive pull, I could do a pull from the very earliest date to the very last date, and then it has all the data inside of it. The problem with doing that is I may know the last day of the calendar year is December 31st, obviously, but that's not necessarily the day that the last day of the stock market was open. So I need to know what the last day of the stock market was and what the beginning date of the stock market was, because it's not going to be January 1st and December 31st. So instead of just pulling one massive pull, I'm just going to pull each year individually, so I know the first date that's in that data set is the first day of the year, and the last date is the last day of the year, regardless of what actual day that landed on. So we're going to call this year 1, and it's going to be stock.history. So history pulls historic stock data, and it's going to be looking for a start date. So start is going to be equal to start dates, and this is just going to be the first one. So that the 0 index, so it's just going to pull the very first start date. Going to do the same thing for end. So end dates at 0. And the last thing we need to tell it is the period needs to be equal to day. Okay, this pulls all of the stock data. Now, the one other thing that I would like to do is I want to reset the index, and I'm just going to pass a drop equals true in here. So the reason for this is going to pull all of these stock data, but the index is going to be based on the date. I am just going to reset it, so it's going to be 0 through n number of days, and it's just going to be easier for me to reference instead of trying to look up whatever that date was that I'm trying to look up. Instead, I can just say I want the very first date and the very last date. And I'm dropping it because I don't want to save whatever that date was. Okay, so copy this. We're going to do this 3 more times because we have a total of 4 years that we need to do this for. So year 1, 2, 3, and 4. And all we really need to do is just update these indices. And that will give us the yearly stock data. So let me go ahead and just I'll display year 4. Run that. Okay, and you can see we have open, high, low, close, volume, dividends, and stock splits for 53 days actually. So this gives us all of our historic stock information. Perfect. That's what we wanted. And that is all of our data sources. So that is a lot of data sources, right? We have 1, 2, 3, 4, 5 for financial documents, and we have 4 for the stocks. So I want to start combining some of these, and a lot of these financial documents up here can all be combined. So that is what we're going to do right now. We are going to say, so for the earnings report, the earnings was the smallest one, and each of the columns were just whatever year it was. It wasn't the actual date. It was just 2018, 2019, and on. So let's go ahead and say those are going to be our default columns that we want. So I'm going to say columns is going to be equal to earnings dot t. Now the reason for dot t is because we need to transpose it in order to get those. So we need to swap rows and columns. So dot t dot columns dot values. A lot of stuff there, but let me just do a quick print to show you exactly what we are getting out of this. Okay, so as you can see, it's just all of the years instead of the dates. And the reason we're pulling these is because I'm just going to go through all of those other documents, and I'm just going to change the dates to be just the years. So I'm going to say balance dot columns is going to be equal to the columns. We're going to say financials dot columns is going to be equal to columns. We're going to say earnings. Now remember, earnings is what I pulled this from, so all I need to say is earnings equals earnings dot t. Because the dates are stored as the rows instead of the columns, we're just going to shift that, and now it's going to match everything else. And the last one we need to do is the cash flow. So cash flow is going to cash flow dot columns is going to be equal to columns. Okay, so this gets all of the arrays in the proper format, makes all of the column names the same. Now we can go ahead and put those all together. Now, one error that we are going to run into is the cash flow has the net income, and I believe the financials also has net income. So there's going to be a collision between these two columns. So in order to take care of that, I am just going to drop that from the cash flow one. So I'm going to say cash flow equals cash flow. There we go. Dot drop. We're going to be dropping the net income. And this is going to ask which axes it's on. Now, since we just transposed it, all of our years are our columns and all of the actual values are going to be our rows. So we're going to drop it from the row. So axis equals 0. Okay, so now we can go ahead and smash these together. I'm going to call the combination just yearly. That's going to be equal to pd for pandas dot concat. And we're just going to concatenate all these. So balance, financials, cash flow, earnings. Okay, now we got all of these. The dates of the columns, all of the values are the rows. I want it the other way. So I'm just going to swap it again. So we're just going to transpose it again. So now all of our different features are going to be our columns, and we're going to have 4 rows for one for each of the different years. Let me display this. Okay, like I said, each of the rows are the year, and then we have all of our different features as the columns. One thing that would be useful is I'm going to define a new variable. I'm just going to call it columns again. I'm just going to pull all of the columns from yearly. So yearly.columns.values. And if I print the columns, you can see, now I can see all of the different features that I can pull from. This is going to be helpful when we, in the next step, which is building all of our indicators to figure out what they're actually called within the data frame. So before we do that, there's a couple more things that I do want to save within the data frame. So we're going to say yearly at, I want to save whatever ticker that we're using, obviously, just so I know what to correlate it with in the end. So yearly at ticker is going to be equal to ticker. I'm going to say yearly at sector is going to be equal to, now if you remember when I printed out the info up here, the sector was included. So I am going to say info at sector, and it's going to pull whatever one it's in, whether it's industrial or finance or whatever the sector is. Actually, I believe this may be lowercase s for sector. And the last thing is yearly. I just want to say what year we're looking at. So year is going to be equal to yearly dot index dot values. So it's pulling the index and it's putting it as a new column. I'll just display this to make sure I don't have any errors. It's not going to be much to see though. I forgot to get rid of this. All right, scrolling over, you can see we have some of those at the end right now. So not much to see there. Now is where we're actually going to get into making some features. First and most important feature is what are we actually trying to maximize within this data set? And that is going to be, we want to maximize the return on investment, right? So we want to say over this stock, given all of these different parameters, increased by 100% over the year, or went down by 20%, whatever that is. So the percent change is really what we're looking for. And so we can go ahead and define that and get it ready for the array, for the data frame. Now to do that, if you remember back up here, we have our 4 different years, and we're just going to go through each one of those and pull those apart so that we can come up with the percent change. Okay, so that's going to be, we're just going to call this start price, I guess. This is going to be the starting price for the year. So I'm going to do np.array. I'm going to store it as an array. And now we're going to go through each one of those years. So we're going to say year 4. Now the reason I'm starting 4 to 1 is because the way I have it saved right now is newest to oldest, and I need it to be oldest to newest to match the form of the other ones. So year 4, I want to dot, okay, so dot locate, there we go. And we are going to be looking for in each of these, if you remember when we pulled each of these different dates, the very first date was actually the whatever one was in the column, and that was actually the last date of the year before. So instead of using that as the starting date, we need to go one step so that we're at the beginning of the year. So I'm going to say the very first row, or sorry, the second row. This is the second row, index 1, for the starting price, and then I want it to be the opening price. Okay, so it's pulling beginning of the year, and it's pulling the opening price. We can go ahead and copy this because we're just going to do that for all of the other ones. So we're going to say year 3, year 2, and year 1. All right. Now we need to close this array, and that will give us all of our starting prices. If I copy this, end price is going to be pretty much the same thing, but we're going to say year 4 instead of the beginning of the year. We're actually just going to take the very last one, so we have to say the length of year 4 minus 1. That's going to be the very last value within the data frame, and instead of the opening price, we actually be using the closing price. I'm going to take this and gonna get rid of all the other ones and just paste these in here. Okay, so now we just need to go through and change all of the years. Year 1 and year 1. Okay, so now we have all of our starting and ending prices. The only thing we need to do now is calculate the percent difference. So percent change from the end to the beginning. So we're going to call this PCT diff. If I can get that right. All right, so it's going to be equal to the end price minus the start price over the start price. And simple as that. Now let's go ahead and store that within our data frame. So I'm going to say yearly at result is going to be equal to PCT diff. And got rid of my display, so I'm going to display yearly. Just to make sure my code compiles, don't have any errors before we go on too far. And it does. If I look all the way over there, yep, the results are there. Okay, so we now have a shell of a data frame that we can use. Now we need to, for the last step, fill it with some indicators. So we need to come up with some indicators that we want to use, and we're going to do that right here in this blank space. Now you can go ahead and Google it. There are a bunch of them out there. I have a list of ones that we're just going to put together. So that is going to be right here. Oops, went down a little too far here. You just tab this over. Okay, so we have all these different ratios. So we have some for liquidity, some for leverage, some for efficiency, and some for profitability. And so you have things like the current ratio, the quick ratio. Those are very two common ones, but you got some other ones like return on equity, return on assets. So, and I put what the actual equations are in here as well. You can go ahead and stop the video if you want, but I'm actually just going to be building each of these ratios right under these notes. So let me just push these over a little bit and we will begin to do that. Okay. Starting off with the current ratio. So we're going to be defining a new column. So yearly at current, I'm going to do underscore ratio. Okay, so the current ratio is going to be equal to what it says right here, the current assets over the current liabilities. If you go down here, you can see it's kind of lost in here, but we have total current liabilities, and there's also going to be one for current assets, which I can't see at the moment, but it's in there. So what we're going to do is we're going to say this is going to be equal to yearly at total current assets, and this is just divided by yearly at total current, I believe it's liabilities spelled out. Okay, so this gives us the current ratio, the current assets over the current liabilities. Quick ratio we should be able to do just as easily. Now the difference between the current and the quick is it looks at the cash on hand and the cash equivalents. So what we can say is the yearly quick underscore ratio. Now there is one thing that is going to be a little harder to do. And so all of this is really just the current assets, but we need to add in some things like inventory. This takes care of, like, if you could sell all your inventory really quick, then that should be included as part of it. So it's going to be equal to, for now, yearly at total current assets. But I'm not going to divide it yet because I need to add an if statement here. So if the company has inventory, so if inventory is included in the columns, remember columns is this massive list I printed down here. So if inventory is included in any of the reports, go ahead and add that to the current assets before you divide. So we're going to say yearly at quick ratio plus equals yearly at inventory. All right, so the reason I'm not just adding that to this line is I've already gone through this, so I know that some don't have inventory listed on there. So I don't want to hit an error and then just skip over the entire stock. I just want to make sure that we cover it if it's not there. So we are going to just say the quick ratio is going to be equal to yearly at quick ratio divided by equals the yearly at total current liabilities. All right, so that takes care of the quick ratio. Moving down to the cash ratio. Again, this is going to be sort of like the one we just did up here. So I'm actually just going to copy most of this. So copying most of the quick ratio, I'll actually just copy all of it. Let me spread these out a little bit so you can see the different ones. Okay, so instead of calling this the quick ratio, we're going to be calling this the cash ratio. And this is going to be equal to the cash on hand Now there's one more thing that we should look for, and that is short-term investments, because that's included in the cash ratio if you have any short-term investments in there. Now if it is included in there, we're going to say add it to the cash ratio. Okay, so we have the cash plus short-term investments, and then we are going to be dividing it by the current liabilities. So cash ratio divided by total current liabilities. Okay, takes care of that one. Two more for liquidity. This is going to be operating cash flow. So yearly at operating cash flow is going to be equal to yearly at total liability. And in this case, I believe it's abbreviated. Let me just verify that. Yeah, total liability right there. All right, so we're taking the total liability, and we are sorry, this is not total liability. This is total operating cash on hand. So total cash from, this might be a capital F, from operating activities. Okay, so I should have read the thing up here. So the operating cash over the current liabilities. I have current liabilities right here. Go ahead and divide that by total current liabilities. Okay, and the last one we're going to do for this section is the equity ratio. So yearly at equity underscore ratio is going to be equal to total equity over total assets. Make some space. All right, so it's going to be yearly at total stockholder equity divided by yearly at total assets. And that will finish out all of our liquidity ratios. I don't have sorry. Let me display yearly. I'll leave this one down here this time so I stop deleting it. Make sure we don't have any errors before we move on. All right, so we do have an error. I spelled activities wrong. Activities. All right, and we printed, so we don't have an error anymore. But you can see those are all added into here, all those different ratios. So we can go ahead and use those. But before we do that, let's go ahead and do some of these other ones. So leverage, debt to equity. This one should be fairly straightforward. We can go down here. We can say yearly at debt to equity going to be equal to yearly at, as you can see up here, is the total liability over the stakeholder equity. So this is total liab. It's abbreviated here, but it's over yearly at total stockholder equity. All right, that takes care of debt to equity. Now we can, I'm going to copy this just so I don't have to keep typing all this stuff out. But debt to assets, basically the same thing, except we are going to be replacing the stockholder equity with the total assets. And the last thing is the interest coverage. So this is going to be yearly at interest coverage going to be equal to yearly at operating income divided by yearly at interest expense. And that'll take care of all the leverage. Let me just finish out efficiencies before we run it again. So I know this is a lot of just listening to me say which ones are which. I've done all of the work and gone through each one of these to figure out which one's actually corresponding with the ones that we want. So it's a lot of work, especially in machine learning, to get your data ready and into a proper format to use. And it's like 80-90% of the effort is trying to put it all together. So I've done a lot of that for you and explored which ones work and don't work in this one. So kind of helps you out a little bit there. But it's a lot of brute forcing getting all these done. So we'll try to get these done as fast as possible. So yearly at asset turnover. This one's going to be equal to yearly at revenue divided by yearly at total assets. I spelled yearly wrong here. And the last one we'll do before we run it is the net receivables. Now, the net receivables, I was having a problem with this one. So I found the solution to this is just doing a if statement here. So if net receivables is in the column, so if this column actually exists, the problem before was net receivables isn't in some of these data sets, so it would break this every single time. So to avoid this, I'm just going to say if it's in the columns, we're going to go ahead and calculate this. So it's going to be yearly at receivables. This is receivables turnover. Okay, this is going to be equal to the yearly at revenue divided by yearly at net receivables. Okay, so if it's in there, great, we're going to use it. If it's not, we're going to say the yearly at receivables turnover is going to be equal to np.nan, not a number. So if it's in there, we're going to use it. If it's not, we're just going to say it doesn't exist, and we're going to use not a number. We run this, see if we have any errors. We do. So interest expense. Let me figure out where that one is. Need to P in expense. All right. Sliding this over, you can see our newest ones are added right here. So we have a lot in there, and we only have one more section to go through, and then we are all set with our indicators that we're going to use. So we're going to use the gross margin. Yearly at gross margin equals the yearly at gross profit divided by yearly at revenue. Oops. This is a capital R. Okay, so gross profit over the revenue. Let me go ahead. I'm just going to copy this one down here because it's fairly close. Instead of the gross margin, this is just the profit margin. And instead of the gross profit, it's going to be the net income divided by the revenue. Okay. It takes care of that one. Now we're going to do operating margin. So yearly, let me keep this consistent. At operating margin, it's going to be equal to the operating income. So yearly at operating income divided by yearly at revenue. Let me space these out again so you can kind of see. Okay, return on equity is going to be equal to, all right, so yearly return on equity going to be equal to yearly at net income divided by yearly at total stockholder equity. Return on assets is, I'm going to copy the first half of this one. All right, so return on assets equal to the net income over the total assets. So yearly total assets. And two more. Now, unfortunately, before we do this one, we do need to come up with a price here. So share price is going to be equal to np.array. This is going to be, I need to know what, at the time of the release of these documents, I need to know what the current share price was because the EPS and the PE go off of whatever the current share price is. So we're going to say it's equal to the year 4. And then we're going to do a dot locate. Now, if you remember, we pulled each of these at the release of the report to a year after. So it's going to be actually the very first row. And I want to know what the close is. And we're just going to take this. We're just going to repeat it for all the different years. So go ahead and change all of these different years, 3, 2, and 1. Okay, so this gives us the share price. Now we need to take that share price and we need to calculate the EPS. So we're going to say, again, this is another one I know that doesn't work all the time because I've explored it. So I need to say if issuance of stock. So what this is doing, it's comparing the earnings to however many shares of stock are out there. Unfortunately, not everyone reports it in the same way, so we have to figure out where they kept their current shares outstanding. So we're going to say if issuance of stock is in the columns, then that's great. We're going to use that as the total number of how much stock is out there. So this is going to be equal to the yearly at EPS. That yearly at EPS is going to be equal to the earnings divided by the issuance of stock. So yearly at issuance of, use the capital of up here, make sure it's a capital O for of, issuance of stock. Okay, great. If issuance of stock is in there, we're going to use that. If it's not, then we have to get creative with it. So we have to say the yearly EPS is going to be equal to the yearly earnings divided by, it's probably not going to be in these. So what we can do is we can just take the info has the total number of shares outstanding for the current year. So just as a default, we can just use the current year and pretend that it hasn't changed over the last 4 years. It's not the greatest, but we can at least get something out of it. So we're going to say info at shares outstanding. I believe that's how it's spelled. And that will give us the EPS. And the very last thing is the PE ratio. So PE is going to be equal to that share price that we calculated divided by the EPS that we just calculated. And that is all of them. Let me run it, fix any errors if we have any. And we do not, so we did something good here. All right, so PE, EPS, all the ones that we calculated is right here in good Good to go. Okay. Now I am going to come here. We don't need to print the columns anymore because we've figured all that out, and we really don't need to display the data frame anymore. So this is what we've done is just for one stock, and this is the 3M company that we've done it for. And actually, we have a lot of like information that we don't need. So we stored everything that we needed in here, or sorry, that we needed at the time, but we don't need them anymore. We basically just want all the ratios that we calculate. We don't care about all the underlying data because it's not going to be the same for all the companies. Some are bigger or smaller, but in the end, we just want to know how much it's going to move. So we need to limit which columns that we're going to be taking. So instead of sitting here and typing all these out, I've actually already predefined this list. So go ahead, and I actually put this in the wrong spot, so sorry. Let me delete it real quick. We're going to be doing it under the result. So go ahead and take a second, pause the video, and get all of these columns, because these are the ones that we're going to be using, and I've also reordered them in a useful manner. So ticker, year, sector, and then all of the ratios that we just calculated with the result at the very end. So again, the result is what we're trying to predict in the end. Okay. So we have all of that. Now we can say yearly equals yearly at columns. Again, columns is what we just defined as all of these. So it's just reducing the size of the data frame down to keeping only these columns. And then I just want to reset index drop equals true. So reducing all these down, resetting the index, and we are good to go. So this is one stock, right? So one ticker, but we're going to be doing these for every single stock in the SP 500. So we need to continuously add this to a data frame that's going to be growing every single time we add one into it. So if I scroll up to the top, we're going to be adding in a blank data frame that right before this for loop that's going to be called yearly combined, and it's going to be equal to a pd.data frame with nothing in it. It's just a blank data frame. The reason we're going to do this is because if it's the very first one, we're not going to be able to add it to it because there's nothing in it. So what we're going to do is we're going to have an if statement down here that says if the data frame that we just created, if it's empty, we're going to set the very first one as the empty array, and if not, then we're just going to concatenate it onto it. So if yearly combined dot empty, this is going to return a true or false statement of whether it's empty or not. We're going to say yearly combined is equal to yearly. If it's not empty, we're going to say yearly combined is going to be equal to pd.concat. So we're going to concatenate two data frames together. And the ones we're going to take is yearly combined. So we're taking itself and we're adding in yearly. And then we're just going to do a dot reset index again. Drop equals true. Every single time we do this, we're adding it to a massive data frame. We're dropping or we're resetting the index every time so that it doesn't have repeat values, and we should be good to go. Now, before I unleash this on the entire S&P 500, there's one more thing you may need to be concerned with, and that is some websites will throttle you if you are sending too many requests. If you remember up at the top here, we are sending 1 request, 2 requests, 3, 4, 5, 6, 7, 8, 9, 10. We're sending 10 requests to this website every single time we have a ticker. Now, for things like Yahoo Finance, the actual Yahoo Finance website, I believe they will throttle you if you do more than 10 requests within 10 seconds. I'm not sure if this API has a throttle limit. I've tested it and I wasn't throttled. I'm not saying you're always not going to be throttled, though. I think it depends on their traffic. So one thing you may think about including is just to have it wait. So you can say start is equal to time.time. So you can say, here's the current time before we started trying to get the stock, right? And then at the very bottom, right after the accept, you can make a variable called time diff, which is going to be equal to the time after we've pulled all this information and put it together. So time.time minus start. Now, if the time diff is less than 10, what we're going to do is we are going to do a time.sleep. We're going to say 10 minus whatever that time difference is. So basically what this is doing is it's saying, okay, has it been 10 seconds? Or has it been less than 10 seconds? If it's been less than 10 seconds, we're just going to wait until we hit that 10 seconds, and then we're going to try again. So it's going to pull a stock every 10 seconds instead of just sending out a massive amount of requests all at the same time. So this will kind of just slow you down, but you may not get throttled by the website, so it may end up being faster for you anyways. That's just one thing to consider when you're doing that. I will run this for a couple, so I'll say yearly combined. I'm just going to display the final result, and then I'm going to do a yearly combined .to CSV. You can name it whatever you want to. I'll just call it combined.csv. Now I want to say index equals false because I don't care about saving the index. And we can run this for more than one. So let me go ahead and just change how many we're looking at. Maybe I'll just do 2 for now because I don't want to sit here and wait for it. Now, this is, like I said, we're pulling one every 10 seconds. So if we have 505 of these, it's going to take 5,000 seconds to do this. So it's going to take, what was that, 2 hours? So this will take a while. And you can see before I get into that, you can see now we have all of our information. We have ticker, year, sector, but we have multiple tickers, multiple years that we've all combined together. So I should mention before I switch topics here, some of these, so if you remember, we added this try and accept. If any error happens, it's just going to skip that stock. There are some in here that I didn't fix the errors on, so I think it skips like 5 maybe, which was all right. Some of them are delisted. Some of them just don't have enough information to pull the history from. So I just went ahead and left those off. We still have a lot of results in the end. We pretty much have the entire SP500 for 4 years, with the exception of maybe 5 of them. Okay, so you can go ahead and run this for all 500. Again, it's going to take maybe 2 hours if you put this time limit in here, or if you get throttled, it may take longer. So what I've done is I've actually posted this on GitHub. So I will put the link in the description, but I also just copy this link and include it right here if you want to stop the video and copy it. But I've run this exact code right here, and then I stopped. And then we'll pick this up in the next video. I'll do markdown language. Okay, so here is the link to the GitHub. You can go ahead and just download that CSV file. Or you can run this code yourself, I guess. It doesn't really matter. But to save you some time, I figured I'd publish it. And so in the next video, what we're going to do is, okay, we got our data. Now we have to fix some missing values, and maybe we have some outliers that we have to take care of. Shouldn't take too long. But then really what we're going to do is we're going to use logistic regression to try to predict, okay, year to year, which stocks should we be looking at in the S&P 500 in order to try to make a profit. And then we're going to compare that to what would happen if I didn't have this algorithm and I just randomly invested in some companies. So this is a good stopping point. We'll leave it here. If you got anything out of this video, please like it. Stay tuned for that next video. Definitely subscribe to the channel, get that notification when it comes in. But for now, I am out, and I will see you next time.